We got to do chain rule, so we'll have 1/2. We'll leave the stuff on the inside exactly the same. And we'll make this to the -1/2. And then we will multiply by the derivative of the inside, which is just going to be 3. Which will give us, if we simplify that out a little bit, we'll have 3 over 2 square root of 3x minus 4. Something to note here about this is this inside part, unless you got like a weird function where something simplifies, that inside part ends up still being in your answer, right? Because when you take that derivative, you leave the inside part alone, and then you multiply by the derivative of the inside. So if we have one like number 2, we've got 3 cosine of pi times x. So again, we have an outside function, which is that cosine, and then we have the inside part, which is pi times x. So to take that derivative, we would leave the 3 outside because it's the coefficient. We would take the derivative of cosine. What is the derivative of cosine? Negative sign. We leave the inside part alone right now, but then we have to multiply by the derivative of the inside, which would just be pi. So that'd be -3 pi sine of pi x. Okay. All right. We're going to do 3. I think I'll skip 4. So for 3, you do not have, that's a minus sign right there too. Looks like a multiplication sign. For 3, you do not have to use chain rule for this problem. What could you use? Quotient. You could use quotient rule. And if you use quotient rule, that would be fine. But because you just have a coefficient here, you could write this problem as 3x squared minus 4x to the -1 power. Okay, so if we write it that way, now we can just use chain rule. So our derivative would be, we'll have -1 times 3x squared minus 4x to the -2 power, and then we would need to multiply by the derivative of the inside, which would be 6x minus 4. And so that, excuse me, if we want to kind of simplify that, I'm going to just put the negative out front. We'll have 6x minus 4 over 3x squared minus 4x squared. So what I want to point out here, again, for both of these that we've just done here, that inside part of our function, that inside when we were taking the derivative, it ends up still being in your answer, right? Same thing here. That inside part, the 3x squared minus 4x, that still ends up being in your answer when you take the derivative. Okay, that's going to be helpful to us as we start. Basically, we're going to be starting with the derivative and trying to get back to the function. This is essentially what we'll be doing today. So, here is our rule for what we're going to call integration by parts. I'm going to let you write it down, and then we'll talk about what it means, and we'll try some. Yes. Yeah. Yeah, if you want, you could add a multiplication symbol there. So these are two different versions of the same rule that we're going to use for integration by parts. So what we have here is we have basically the result of the chain rule, right? We've got f of g of x times g prime of x, right? That's what we get when we take the derivative of f of g of, or capital F of g of x, right? Like if we started with capital F, this capital F, its derivative would be lowercase f. So we get lowercase f of g of x, and we'd have to multiply by g prime. So what we're seeing is we're going from the answer from the chain rule back to what we started with. So the g of x that you see here, in that second version of the same rule, they have used a u, and, well, let me use different colors here. They have used a u instead of a g of x, just to simplify the notation, and then the g prime of x dx, they used a du for. So u here just represents some sort of equation, right? It could be x squared plus 4. It could be e to the x. It's the inside part, right? You could also use g of x to represent that. I prefer this notation, although I will admit every time I see f of u, it seems like I shouldn't say that because it almost seems ugly. But I prefer this notation, and it's what we're going to use generally there. And so we see f, capital F of u plus c. Again, that u is that same thing as the g of x here. It's your u inside part. Du is the derivative of g of x. Yeah. So let's look at how to do a problem. I'll let you copy this problem right here down. U represents the inside function. F and U do not represent words here. Yeah. Not really. So just like our rule for integrating for the indefinite and the definite's the same. The only difference is when we have definite integrals at the end, we have to plug those numbers in and subtract. So it's going to be the same for this. Today we'll be doing indefinite, so that means we'll have the plus c on the end. Whenever we get to doing these same problems in their definite integrals, it's going to be the same rules and the same process, but we won't have that plus c because we'll subtract within. There is going to be like one little trick we can do with it that's a little further down the road. Okay, so here is what we've got to do for a problem like the one that we see here for example 1. Okay, so what we're looking at is the result of a chain rule. Now, you do have the option on this. You could multiply this out, distribute the 2x, use regular integration rules, right? That's a possibility. But your answer choices are probably not going to be presented in that manner. They're going to be factored back out, so it's going to be kind of hard to do it that way. So something like this is generally going to be intended to be done using U substitution. And we're going to get into some that have to be done using U substitution. So U substitution is going to look like this. What we're looking for is what the inside part of the function is. Okay? So we want to find what would have been the inside part of the original function. So what part looks like it's an inside part? Something maybe raised to a power. X squared plus 1 looks like our inside, right? Sometimes it's very obvious. Other times it's not quite as obvious, and you have to kind of play around with it a little bit. So what we're going to do is we're going to let U equal x squared plus 1. So we are saying that U, our inside part of this function, is x squared plus 1. So what we want to do is we want to take the derivative of that. So du dx will equal just 2x right here. Okay? Now, notice in this formula that I have an f of u, and then I have a du over here. That's not a du dx, it's just a du. So the way that I can get this to be just a du is I could take this and multiply it by dx on both sides. So now I know that du is going to equal 2x dx. So what I can do is I can substitute here. Do you have a question? Okay. I can substitute. So u equals x squared plus 1. So I can take this x squared plus 1, I can put a u right there. And then my du equals 2x dx. Well, right here is 2x dx, so I could replace that with du. So now my equation is going to, or my integral is going to look like this. I'm integrating u squared du. Okay, everybody with me here? And what I want for these problems is I want everything to be in terms of u. I don't want any x's left. So fortunately here this was, my du was there in the problem, right? And then I could replace this right here with u. You may still have exponents left, you may have roots left, you may have a natural log or something like that left, but you should not have any x's left in your problem. Now, if I integrate u squared du, do I know how to do that? Can I take the integral of u squared? That's just basic power rule, right? So what I've done is I have broken this down with substitution so that I just have a basic power rule that I do know how to take the integral of. So what I'm going to get whenever I do this is I will do, I'll increase my exponent by 1, which will be u to the third. I'll have a 1/3 out front. And then what do I have to put on the end? Plus c. Okay, so I'm integrating there. When you integrate with respect to u, it's going to get rid of that du. And it's mathematically this is not correct, but more or less the du gets replaced with a plus c. Okay, I'm not quite done because I still have a u in my problem. And my problem was in terms of x. So I need to get this back to x. So all I have to do now is just plug back in. I know that u equals x squared plus 1. So I'm just going to plug that back in over here for my u. So it'll look like this. 1/3 x squared plus 1 to the third power plus c. Are we okay here? All right, that's my answer. That is the integral of x squared plus 1 squared times 2x dx. You can always check your answers for these. So to check, we just need to take our answer and take the derivative of it, 1/3 x squared plus 1 cubed plus c. So if I take the derivative here, it's chain rule, 3 times 1/3 is just 1. I have x squared plus 1 to the second power. I will multiply that by the derivative of the inside, which is 2x. Let's see. The dx, the way I've written it, the dx, kind of, if I do it, let me do it a different way so the dx shows up, not notations. Great. So if y equals this, then dy dx is going to equal this. What's the derivative of c? 0, because c is a constant. And then I would, if I want to know just the dy, I would multiply both sides by dx, which would give me that dx that's over there. So if you take the derivative of what you started with, you will get, or if you take the derivative of your answer, you should get what you started with for these. So it's not necessary to check on all of these, but you can always do that if you are unsure if you did it correctly or not. Okay, questions? Now that is about as easy as U substitution is going to get, as you can imagine. We don't usually start off with hardest ones because the du was already there for us. So let's look at a different problem. It's not a lot different. Actually, this one's still going to be easy. This one's not that difficult. It'll be the next one where we're going to have to do a little more work. All right, so we've got the integral of 5 cosine of 5x dx. And so I can't just integrate this because of that 5x. If it was just an x, I could just integrate. The 5 as a coefficient, it's fine. But because I've got more than one thing inside right here, I can't just integrate that. So this is one that's going to be a chain rule. We're going to have to use U substitution for this. The inside part is going to be your u, which for this one is 5x. If we take the derivative of u with respect to x, du dx is going to be 5. And then to get that du just by itself, you would multiply by dx, so 5 dx. If you want to start skipping that middle step right there and just automatically putting your dx over here on the side, that's perfectly fine. So, like the last problem, we want to substitute. So, I can see right here I've got my 5x. I can replace that with a u. Do I have 5 dx? They're not together, right? But I could rewrite this like this, cosine of 5x times 5 dx, like that. It doesn't matter if that 5's out front or if I put it back here with the dx. So I'm replacing this 5x with a u, and I'm replacing this 5 dx with my du. Okay? And so when I do that, my integral now is going to look like this, cosine of u du. Okay, here. Cosine of u du, we should be able to integrate. What is the integral of cosine of u? Sine. So, sine of u plus c. Got to remember that there. And then we're just substituting back in. So we're replacing our u was 5x. So we're going to do sine of 5x plus c. And that will be our answer. You can always take the derivative of this to check to make sure that it works. Hello? Yes. Uh-huh. Mm-hmm. Oh, no. Uh-huh. Okay. Okay. Yeah. Let me check and see if my husband can come get him, or if not, I can come get him. Okay. All right. So, one of us will be there soon. All right. All right. Thanks. Bye. Here, grew up. So, I've got to. Okay. Let me show you how to do one more problem. One more. You need to know how to do this next one because you can't go anywhere. All right. One more problem, real fast. And then I gotta call my husband and see if he can get him, and then I'll. Okay. So this one, your inside is this. Okay. So inside is x squared plus 1. So that's going to be u is going to be x squared plus 1. That means du is going to be 2x. And I'm going to go ahead and just put the dx over here because that happens every time. Instead of writing that step with the du dx and multiplying it. So our issue this time is that if I write this way, if I do x squared plus 1 squared, I've got an x and a dx, but I don't have the 2. And to replace that with du, I have to have a 2 there, and I have to have the du before I can integrate. So what we can do here is I can just add a 2 right here as long as I put a 1/2 out front, because 2 is just a coefficient. So I could put the 2 here, and that's fine as long as I also put a 1/2 out here, because that coefficient will cancel out with the 2 and will not change the value of this function. So sometimes you may be missing part of the integral there. So you are going to have, when you substitute here, we're going to substitute our u right here, and this part right here is our du. So it's almost like the last problem, but we've got that 1/2 that had to be put out front. We got u squared du. And we will integrate. So we'll do u to the 3rd power, and we'll have 1/3 out front. Put a plus c. And so that'll give us 1/6. You can plug the u back in, and this will be your answer. So sometimes you're going to be missing part of what you need for your du. But as long as it's just a coefficient, you can add it in as long as you do 1 over whatever that was out front. Does that make sense? Good question. It can, but C is an unknown value. So if we do distribute the 1/2, we will get 1/2 C. Half of C is half of an unknown value, which is still an unknown value. So basically anything you do to a C, whether you add something to it, subtract something to it, multiply, square, whatever you do to a C, just doesn't really happen because it's still just an unknown value. So you don't have to do anything special with that. If you put 1/2 C, it would still be okay, but it's not necessary. So I generally just, the C is kind of immune to whatever happens to it there on the end. Right. Okay? All right. Try this one while I go work on a solution to my problem.
I don't know what to do. What's U? U is 3x to minus 5. Yeah. And what do we need to use? Oh, so it's just I just
I'll call Doctor here in a second. We'll do this one.
And now once you get that, what you do is you substitute. Do we not need to like, why do we not need to like put like a 1/2 or something?
In front of the when you're multiplying 3 by the 1/3, you get 1.
So because this is a 3,
Yes, because it's 1/3 times 3 is.
wait, I don't know what to write down. I thought my notes were easy to follow, but mistaken. Oh, so I just put like U where the function is.
It just depends. There's not like a standard way it has to be left. So it might be left like this. Sometimes they'll leave it with negative exponents. Sometimes they will distribute. Sometimes they don't. So just, it's good practice, like back of the textbook, try to get your answers to match, because that'll kind of help you practice for multiple choice situations. All right. We okay here?
So what do you do after you put the U back in? Because I just don't, I don't know if I'm like writing steps ahead, like the equation, or like steps behind.
Like when to integrate.
Like I have 1/3 the symbol u to the negative 2d.
Yeah, this is good. Yeah, right here. So then, once you get it to where you can do like the power rule, you want to integrate. So
I never put a 3 in the equation.
You have the 1/3 though, right?
Yeah.
So the 3 that you put right here, you have to put a 1/3 out front to balance it. But then this 3dx gets replaced with the du. So that 3 right there is not going to show up over here once you've substituted.
Oh, I don't think that's a...
Okay, other questions?
I have a negative 2 on the bottom of the
Make sure you want to increase your exponent 1 first, and then you're dividing that coefficient. So like right here, you're that negative 2, you're increasing it to negative 1, and then you got to do 1 divided by that negative 1. You may have divided by the exponent as it was first. So you got to increase the exponent first, then divide by that exponent. And then that, you got the 1/3, and then that negative u to the negative 1 is going to be negative 1 over u to the first power, which is going to give you that negative 1 over 3u. Plus, you can distribute the 1/3 to the c, but you can basically just leave the c alone there. And then we just plug this back in.
So you don't leave the exponent with the 3x minus 5. Because I moved it up.
Oh, you put the square from the beginning in there with it. No, you don't. The u is just 3x minus 5. It's not 3x minus 5 squared, so you don't put that exponent from the beginning back in. Yeah. So whatever you have as your u right here, it gets plugged in right there exactly. Nothing extra from the beginning. Okay. All right. Now, I just want to throw this in here because on the assignment, you're going to see somewhere you don't have to actually use integration by parts. This problem, if you try to integrate by parts, you're not going to get anywhere. Because if I take the derivative of x plus 2x squared, I get 1 plus 4x And that is nowhere to be found in the problem. Or if I take the derivative of the square root of x, I'm not going to get any of that other stuff, right? This is not an inside-outside sort of problem. And they have thrown a few of these in with the u substitution to make sure you're paying attention. This is one where you would use the love connection. Okay? So you would have dy dx equals x over the square root of x plus 2x squared over the square root of x, which I guess I could have done fractional exponents there. So fractional exponents, you're going to subtract those exponents. So you're getting x to the 1/2 power plus 2x to the 3/2 power there. And then technically you got to multiply both sides by dx there. And then you are integrating both sides. So when you integrate this, it's just power rule. There's no u substitution on this. You don't have an inside and an outside. You're just doing x to the 3/2. And then out front, you got to do 1 divided by 3/2. And then here, you'll get x to the 5/2. And then over here, you'll divide by 5/2. And you'll put your plus c. And we want to simplify that. So this is going to give me 2/3. X to the 3/2. And then 2 times 2/5 is going to give us 4/5. X to the 5/2 plus c. So on the assignment, you may run into some where you don't use u substitution. So remember that you don't have to do it on everything that's a fraction or looks a little complicated. Mm-hmm. I'm going to flash right back to this to see. Let me look. 5 through 23 seems kind of a lot. Let's see. What page was it to? 341. All right. 341. It's really not that bad. Alright, I'll take a couple off. Let's do 7 through 23. Alright, so I'm going to make your assignment. I'm going to take a couple off. 341 is going to be, let's do 7 through 21 odd. 7 through 21 odd. And I need to go call the doctor and see if I can get here. So, you guys work on that for a second.
Someone's always pretty hard. Oh, right.
Almost. This goes away. So you're replacing that negative 2x with the du.
Yeah.
And then when you integrate, you're just getting this. The du goes away and becomes the plus c. So you don't have the du there anymore.
Okay.
So you won't have that negative 2x. You
Okay.
just have the plus c on there. Henry did say he was sick this morning. I told him he was faking to get up off the floor and go to school.
Did you get in a
I mean, I did take his temperature, and I checked his throat, and it's red, but it didn't look like all blistery.
Oh well.
Yeah. And it also was suspicious because Hunter was like up there telling him stuff. Like I think Hunter was like giving him hints on how to get out of going to school, or at least that's what I thought. Yeah, like he said his stomach hurt, but he also didn't eat breakfast this morning because he said he was just going to eat at school. So,
Well, okay.
yeah,
Okay.
Yeah.
Just goes like the breakfast.
yeah, I think so. Their TA might take him, I'm not sure, but they,
But it hasn't yet.
yeah, I don't know that Hunter ever did. I think he does it because everyone's on Hunter wants to do it. Like some of his friends like to go eat breakfast.
It's not
because they get to leave class and hang out
second
in the lunchroom. So I think that's why Henry wants to do it sometimes.